Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. In this video, I will explain the material at meeting 9. Who I respect, Mr. Profesor Dr. Haji Sutarto Hadi MSc, Miss Kamaliah MPD, and Miss Rahmita Narbaiti MPD as a lecturer in Mathematics English courses. Let me introduce myself. My name is Tiara Paramita. My ID number is 211-011-8120008 from group 9 in Mathematics English courses. Here I will explain about chapter 4 about geometry. Okay, the point 1 is vocabulary. 1. Trapezoid. A two-dimensional flat shape formed by four edges, two of which are parallel but not the same length. For some types of trapezoid is the first in the picture is called trapezoid. Trapezoid with equal length are the non-parallel sides. So type 2 is right trapezoids. Trapezoids that have one pair of right angles. 3 is Kellner trapezoid. Trapezoid that do not have equal sides or angle. So, in here, do not have equal sides or angles. Next, vocabulary 2 is parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. The opposite sides of a parallelogram are equal in length, and the opposite angles are equal in measure. Example, in the picture here, side AB equals sides DC, and sides AD equals to sides BC. Vocabulary 3, rectangle. A two-dimensional flat shape formed by two pairs of sides, each of which is the same length and parallel to its partner, and has four angles, all of which are right angles. Example, sides AB equals sides DC, and sides AD equals sides BC. Okay, vocabulary 4, square. Square in geometry, a plane figure with four equal sides and four right, 90 and four right 90 degrees angles. Example in the picture here, sides PQ equals to sides QS equal to sides SR equal to sides RP or PR. So the next vocabulary 5, rhombus. Two-dimensional flat shape has two diagonals. The two diagonals can have different values, but the sides of the two rhombuses are still the same sides and the opposite right angles are the same. Example, rhombus ABCD. ABCD. Sides AB equals to side BC equal to side CD equal to sides DA or AD. Okay, the diagonal AC equals to 12 centimeter. Why 12 centimeter? Diagonal A to C equals AE plus AC. AE equals to 6 centimeter. But sides AB equals to sides BC equals CD dan equals AD. We have AC to 6 centimeter. So AE plus AC equals 6 plus 6 centimeter equals 12 centimeter. The diagonal BD equals 16 centimeter. Why 16 centimeter? Yes, the diagonal BD equals BE plus ED. BE equals 8 centimeter, ED equals centimeter. But sides AB equals BC equals CD equals AD. Next, vocabulary 6, kit. In Euclidean geometry, a kit is a quadrilateral with reflection symmetry across a diagonal. Example, from picture, from here picture, we know has two pair or equals and non-parallel sides. Two angles BAD equals to angles BCD. So angles A equals angle C. 3. Diagonal AC. Diagonal AC perpendicular diagonal BD. So AC perpendicular BD has one axis of symmetry that coincides with the line AC. The next vocabulary is vocabulary 7, circle. A form consisting of a point in a plane that are a certain distance from a certain point. Example, from the circle, we have in here to here is radius. Example, from the picture circle, we know from here to here is radius. So is here to here equals radius. From here to here equals diameter. Seperti ini juga, from here to here is diameter. From here to here is radius. So the diameter is 2 times radius. And here is chord. Okay, the next vocabulary is area. The area is the amount of space occupied by a two-dimensional figure. It is measured in square units such as centimeter square, meter square, h. Example, find the area of a square with a side of 7 centimeter. Solution, area of square equals sides times sides. Here, we know side is 7 centimeter. Substituting the values. So 7 times 7 equals 49. Therefore, the area of the square equals 49 square centimeter. 9. Perimeter. The distance around a two-dimensional shape. Example. Perimeter of a shape from the picture here equals sum of all its sides. Therefore, perimeter of the given shape equals 7 plus 3 plus 7 plus 3. So, equals to 20 centimeter. The last vocabulary is circumference. The length that surrounds the circle. Example, if the radius of the circle is 28 centimeter, find the circumference of the circle. Solution is given. The radius of the circle equals 28 centimeter. To find the circumference of a circle, we will use the circumference formula is 2pr. P is 22 divided by 7 or 3.14. So 2 times 22 divided by 7 times 28. R is 28. So equals 176 centimeter. Therefore, the circumference of a circle is 176 centimeter. The next material is about video. Video about circle, radius, diameter, circumference, and P. The question is, what is circle and what are the properties of the circle? So, circle is all of the points that are equal distance from the center of the circle. We're gonna focus to understand some of the properties of the circle. One is radius, R. The distance from the center out to the edge. Radius is here from here, here, from here to here, from here to here, from here to here. So, can be side. Radius is from the midpoint to end circle. So from midpoint to here to here to here is radius. 2 is diameter, D. The distance along the widest point of the circle. It has a very easy relationship with the radius. So, diameter is 2 times radius. So, if diameter is from here to here, if radius is here from here to here, and we know diameter is 2 times radius, so diameter is from here to here, from here to here. So we have diameter is from circle to circle through the midpoint. Nah. Okay, 3 is circumference. Circumference is the perimeter of a circle of measure around the circle. Circumference is um, circle. Okay. Next, how the circumference relate to diameter? Um, we know from the definition radius and diameter. Diameter is 2 times radius. So this is from the circle. This is a circumference and this is a diameter, and from here to here is radius. The ratio of the circumference to the diameter is circumference divided by diameter. Okay. Many thousand of years ago, uh, we to the example. Many thousand of years ago, people took their tape measure out and they keep measuring circumference and radiuses. They kept measuring until they got better tape measures, and they got circumference divided by diameter equals 3.14159 divided by 1 equals 3.14. The name is PR. Yes, lemangnya seperti ini. Okay, the circumference divided by diameter equals P. So circumference equals P times diameter. Diameter is 2 times radius. We substitution P times 2 times radius. So the formula of circumference is PD V times diameter or 2 times P times radius. Okay, next material. We explain about example. Okay, example 1. Duration of the measures of the angles of a triangle are 2 to 7 to 9. Find the measure of the largest angle. The solution is, let x be a multiple. So the angles are 2x and 7x and 9x. As we know that the sum of the angles of a triangle is 180 degrees. So the equation is substitute x to, so the measure of the largest angle is 2x plus 7x plus 9x equals 180 degrees. So 2 times 7 times 9x equals 18x. 18x equals 180. X equals divided both end side divided by 18. So we have x equals 10. From x equals 10, substitution x to 2x, 7x, and 9x. So 2 times 2 times 10 equals 20. 7 times 10 equals 70. 9 times 10 equals 90. So the largest angle is 90 degrees. Okay, next example 2. Shovels of equal length are supporting a vertical antenna in an arrow. Each is attached to the top of the antenna and to a spot on the rooftop. If the cables from a 40 degrees angle with each other, what are the measures of the angles formed by the cables and the rooftop? Okay, the solution is first we can draw a rooftop. First, we can draw triangles. Uh, is a rooftop. Okay. In here, angles is 40 degrees. Here is cable. Here is cable. Here is at antenna, and here is rooftop. The solution is, since the cables are of equal length, the triangle has equal sides and is therefore isosceles. In an isosceles triangle, the angle is opposite. The congruent sides are congruent. Using this along with the fact that the sum of the measures of the angles of the triangle is 180 degrees. We can derive an equation to solve. Let x be the measure of each of these congruent angles. So, um, from angles here is x angle. This is angle is x, and angle is 40 degrees. So all mul- uh, we so all angles we addition x plus uh 40 degrees equals 180 degrees. So to x equals 40 equal plus x, I'm sorry, 2x plus 40 equals 180. So, both end side, we subtraction 40. So, 2x equals 140. Both end side divided by 2. So, x equals 70 degree. So, the measure of the angles formed by the cables and the rooftop is 70 degree. The next example is example 4. At the same time in the afternoon, 6 feet person casts a shadow that is 10 feet long, while a nearby flagpole casts a shadow that is 22 feet long. To the nearest foot, how tall is the flagpole? We can draw. This is person. This is ha. This is a person shadow. This is a flagpole shadow is 22 feet. This is 6 feet. Person shadow is 10 feet. and pledgeable is ha. From here, we know pledgeable shadow um, equals 22 feet. Person shadow is 10 feet. So from here, we have 22 minus 10 equals 12 feet. Okay, so we solution is some basic assumption must be met. 1. The person and the pledge pole are standing perpendicular to level around ground, and 2. The sun's rise from the some angles with the head of the person and the top of the pledge pole. Since corresponding sides of similar triangles are in proportion, we have height of person divided by length of person's shadow equals height of flagpole divided by length of flagpole shadow. Let H be the height of the flagpole, and we have 6 divided by 10 equals H divided by 22. Cross multiplying gives us 10H times I'm sorry, time 10H equals 132. Both and side we divided by 10. So H equals 13.2. Equals 13.2, we run down equals 30. The height of the flagpole, the nearest foot is 30 feet. 13 feet. So the last example is example 5. One of the shorter sides of a rectangle in extended um, 10 units beyond a vertex, and a line segment is drawn from its new endpoint stroke, the rectangle to the vertex opposite the vertex extended stroke. This segment cuts the side it is drawn stroke into the segment of 15 and 24 units. What is the area of the rectangle? Solution is we can draw here um, we draw uh, a rectangle we draw a triangle ABCD, and we draw triangle uh, CEF, or we can draw a timeline AE AE to BC. Okay. The solution is, suppose that we extend site BC through C to a new endpoint E. The problem tells us that CE equals 10 units. The vertex opposite C is A, and we draw segment AE, which cuts site DC at F. The problem tells us the DF is 24 and FC is 15. The diagram makes it clear that there are 296 similar right triangles, A double ADF and AECF. Since corresponding sides of similar triangle are in a proportion, we have AD divided by AC equals DV divided by CF. Double ADF and AECF Signs corresponding sides of similar triangles are in a proportion. We have AD divided by AC equals DF divided by CF. Or AD divided by 10, but AC equals 10, equals 24 divided by 15. This AD equals to 240 plus 15 equals 16 units. So the area of the triangle is 39 divided times 16 equals 624 square unit. Okay, that's my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.